Okay, Chapter 6. And looking at Chapter 6, it's mostly what I would call your basic computer architecture, going back to your understanding of what goes on inside of a computer and a little bit of what goes on inside of a network. So your text calls it the premises technologies. And as you go through it, you can see first page talks about the computer. Interesting little quote at the top of the page here from Einstein. Everybody is a genius. But if you judge a fish by its ability to climb a tree, it will live its whole life believing that it's stupid. Okay, so I've seen that done as memes and different things. It's quite a remarkable statement. So as we go through this, the computer, for all its complexity and capability, a typical computer has a small number of functioning components. And as you go through, you can look at the diagram at the top of the next page. 228 shows the CPU, the main memory, secondary memory, input-output devices, and you'll notice that they are all connected to a bus, and that bus is basically a parallel structure so that each one of those integrated components on here can talk to each other fairly quickly, not in a serial, but a parallel fashion. So you've seen this before. If we look at it, they're the central processing unit, the CPU, the main memory, the secondary memory, input-output devices, sometimes called I/O, and the parallel bus that ties all of these elements together. So that's pretty obvious, from the diagram here. The other thing that it talks about here is the operating system. And between computers, you have different types of operating systems. Back in the day, DOS became Windows. From Unix, we had Linux, the Mac operating system. So we have lots of different options there for operating systems, depending upon the platform that we are operating. CPUs have gotten to be quite fast. It's incredible how over the last 30 years or so, how quickly we moved from the 286 up to where we're at today in terms of how quickly and how powerful a CPU is. You keep seeing articles about CPUs at some point becoming less electronic and more biometric, if you will. We'll see if that day ever comes. Inside of your computer, the CPU, of course, is mounted on the motherboard. And then from this picture, you can see that you've got everything else mounted around it. Several different cards, the power supply, the motherboard in the back, and your bus cables. You've got your RAM, your available memory mounted on the motherboard itself. So this text, it goes through in this chapter giving you a quick refresher of the hardware inside of your computer. It talks about CPU subcomponents. Subcomponent then are all part of the system, the clock, the arithmetic logic unit, the ALU, and an array of registers. So when you get into your studies of the nitty-gritty inside of a computer, you would get into those specific substructures. The main memory, of course, the random access memory or reading available memory. Another measure of the goodness of your computer. Again, memory capacity, the size of memory, how much memory your computer will hold. It grows. They keep talking about, in the past, they've talked about the law that says that every 18 months everything doubles or halves. RAM is silicon-based, solid-state memory, extremely fast in terms of access speed. Secondary memory become very popular line in business, evolving in the PC market. In your secondary memory, then you can have lots of different things, everything from get it out of here, your thumb drive. I keep my thumb drive handy. I keep things that I don't want to keep on the computer in the thumb drive. Backup drives, there's lots of different places. Cloud, SD cards, micro SDs. There are any number of available secondary devices that you can use for memory. Your I/O devices, then input, output, anything that you connect to your computer that either feeds into the computer so it can be operated on, or anything that leaves the computer. Of course, leaving the computer would be your printer. An external hard drive would be an input device. Your keyboard, your mouse, your monitor is an output device. All of these things are mounted on the structure that connects to the bus. And the idea, like I said before, the bus on the computer is a parallel network, and it allows you and your computer and your I/O devices to communicate very quickly with the CPU and the other devices that actually do things for you in the computer. The text also goes into some historical looks at mainframes, tape libraries, arrays of large disks. This was an interesting. I've seen this many times when I worked for the Department of Energy, where you could lift up the floor and you could actually see all of the cabling that runs within the room or between rooms in your organizations. Mini computers. Then they talk about the entrance of the from the mainframe computers, the entrance in the 70s and 80s. Specifically more so the 80s into the 90s. The personal computer started to advent, and people started owning their own computers at home. Page 243, the book talks about LAN basics and characteristics. Again, as we've mentioned before, the type of local area network that you have or that you build will depend upon your particular structure. The text actually goes into the basics of the building blocks. The bus network, where everything, of course, is on a straight line representation, to over here where you have the star, or in this case, they're talking about the token ring configuration, but that could be considered like a star. Local area network access schemes, page 245. They talk about something called contention-based local area networks, where you can go in and you can set up who gets what when, and actually prioritize who gets on the network and who gets to operate on it first, who gets the priorities. That's your priority schemes. Okay, they talk a little more about the basic bus, and then the bridged local area network. On page 249, 250, we get into LAN switching. And the text talks about layer 2, layer 3, layer 4 types of switching. Take a look at those. In each case, they are differentiated just a little bit in terms of how we switch and get information on your local area network. Distributed polling for LANs, again, who gets what when. They talk about on page 253 the decline of the token area network, or the token passing type network. And then the last part of the chapter here gets into Wi-Fi, spread spectrum, frequency hopping, different ways of passing information on the network and or securing information on the network so that there are folks that can and cannot access. 259 talks about Wi-Fi today, 802.11b and G, and the frequencies, 2.4 gigahertz. And then they go through on page 260 and 261 each of those Ethernet configurations here, 802.11 and all of its subs. Wi-Fi in action, Wi-Fi security, and some other things that are less known. The final three: FireWire, Thunderbolt, and USB. So chapter 6 pretty much gets into the basics of computer architecture.